Welcome to a new test and teardown video. This time I got another Heathkit. The Heathkit microcomputer learning system. I think this one can be as old as 1977. I think this is when they released the first version of this system. And it is in a, of course, used condition. It needs a little bit of cleaning up and all that. I got this at the latest flea market auction. And when I shake this a little bit careful, I can feel we got some loose parts. So I'm a little bit skeptical I don't just plug it in. Maybe this is not supposed to look like this. It looks like we got some cracked parts here. I'll have to look this up. Yeah, this is probably exactly the same hole as this one. So something fell into it here, right? I also got, let's see if I can move this. I got all the manuals. I think quite a few. That will be more or less the same, but they are a little bit different, the different manuals. When I look this up and poke around in the material, I find all sorts of things, all the illustrations, all the schematic, circuit board layouts. I mean, I got everything, and how to do this and how to do that. Really fascinating. It's also called, yes, exactly, ET3400, and there is an A version. I can't really remember what is the difference. I think it has something to do with this crystal up here. I think that is how you identify easily if it's the A or whatever it is. Oh, nice to have oscilloscopes. Yeah, definitely machine language. So we need to learn a little bit about machine language as well. This is going to be something. And we also got this. So that will be the manual, and this is the kind of the normal Heathkit manual, sort of speak. Oh yeah, this one says it's the A version, and then there is, yeah, not even unpacked, and this one is copyright 1981, and I think this one is okay, also 81. Yeah, there was definitely something I really wanted to show you. Let's see if I can find this. Here it is. See, in one of the manuals, I find the big, high quality, fold out schematic with everything super duper high res. It's a little bit funny. It has been copied from some other formats. So we have these little. Well, and that is something I was looking for. So this is tape 2, side A and B, and I think, yeah, this is from 1977. This is the text that goes along with all the reading material here on all the how to do this and how to do that. So this is a self-study sort of educational speech about exactly what is going on. If you find it easier to listen to something while you're reading around and all that, that is just absolutely fantastic. And I am a little bit curious if I'm able to find tape 1 online. Otherwise, if I can't find the audio content from these tapes, I only got tape 2. Then I would like to to make this digital and share this somehow, because I think the rest of the material is already available online. If I am mistaken here, please tell me in the comments, and I will of course scan whatever material is needed, and to be able to share this with you guys for the future. So I'm now inside, and I find it is assembled with self-tapping screws into those plastic parts in the top. See, one is broken, the rest is fine, and that one is still here, so I can glue that on. But the rest of the screws there are missing, so that is probably why this one broke the first place. So we got one broken and only two screws. But the parts that I find here, that's some of the plastic parts I need for this hole at the back. So I can also glue this. And inside I see this is not the original transformer. And there's just a rectifier down here. There's probably just a fuse and maybe a filter in here. Let's have a little open and see what is in there. Oh dear, what is all that stuff? Filters and capacitors and a lot of funny stuff. That looks bad. But anyway, let's just keep that as it is. And now we got no loose parts. I don't got any leaked capacitors, at least not too much. So I think we're just gonna try and power this thing up and see what is going on, right? So I'm ready for the first power up, and I'll have it in standby, and then I'll power on mains, and it's using 7 watts, and I think that is quite normal. I will turn off the light because we should see a very special. That is the best you can see. This is exactly what it's supposed to do. CPU is up. Lucky me. That is one good day. So let's try and test this unit a little bit deeper. When it says CPU up, that means it did run the initial setup from the EEPROM, and it's now accepting all sorts of inputs on the little keypad here. So in the manual, I find this test chart too. And I think this is probably one of the most simple pieces of software you can input into this computer here. So, and it even says exactly what to do. And I really, really like this idea. So first press reset. Okay, and then it reads this. This is where we are at, right? So if you hit this auto, it will let you input data input into addresses. And then you just start with what address. RAM is at 0000. This is the first address in your user accessible memory. And then you input, this is the machine code numbers. I mean, this is the opcode for load accumulator with the next character. So we load accumulator with 01. Okay, so that is how it works. And then we store accumulator to extended address this. So that means this data 01 gets transferred to this address in memory, and then jump to 0000. So that means the program just loops back again. It's not doing anything else, just doing it again, right? And then when you're done inputting this, you hit reset, and then you're done with this auto addressing sequence. Now you can do means like run at what address. So you can have many different programs in your memory, and you just put in 4 zeros, and then it will run your program. So let's try and see if I can figure this out, okay? Reset. Then auto addressing. Let's start with 00. And then we put in 86. So now it is pointing at 1. That's perfectly fine. Then the next is 01, B7, C1, and then 6F, 6F, and then 7E, and then 0000. And now we reset. So now we have input the program. Now let's try and run it with this do, and then we put in 0, 0, 0, 0, and then it runs the program. Now it looks like the program is not doing a lot of much, right? But what you will notice is this little decimal point here is lit. And the fun thing is this display here is at that address in memory. So here is the address for that first digit, and the 01 data that we are writing to that address is that that data is driving that LED, and that is proving that this program we just input is doing exactly what we want. Aren't you fascinated? I mean, and all this is of course explained in the manual. Here is the 7-segment display, and it explains exactly about what is going on. And it also says if we go to this address and change the data, we will be able to change the behavior of our program. So let's try and do that. So let's try and do this change to the program. Let's reset. It will say CPU up. Okay. E for exam. We go to an address. And in this case, we want to go to 0, 0, 0, and 4. And now we want to change. And that is done with C. And then we put in 6E. And that is 6E. And then we reset. Now let's try and run the program. And now you see what happened. The upper segment of the first here is now the one that is lit, and that's because we changed the data. I think that is a little bit fantastic. We can change programs, and we know how to navigate the program space, and we know how to start a program from whatever address. And this is what we learned during those two pages, and that is, I think, the rest of what I want to go into details when it comes to programming and all that, because I found on YouTube a million super duper fantastic good videos about this unit, how to program and how it's working, and everything in super fantastic detail. So there isn't really a lot of need for me to repeat everything or inventing everything once again. I think I got what I came for. I wanted to prove that my unit is working, and for that, this has been done here. So this is the material that I got. Let's try and zoom out a little bit so you can see how. So you can see how much it is. And it's all different. So let's look at the indexes. So this one, see, advanced PAA, parallel interface, and analog conversion. And then the next one looks a little bit like that. But see, it's completely different with the indexes. And then, of course, I got all the schematics, I got the illustrations, I got this little flip chart here. It's very useful for remembering all the handy stuff, what you're doing and what of this and that. And then the other two here, I believe, they're also different. Oh, and this one is a change node. So this one probably needs to be unpacked and goes into some of these, right? And the 6809, is this here? 6809, but I believe my processor is called 6808. Well. So that will be all the indexes for this one. But it looks a little bit like the same here. But again, all the indexes, they're completely different. That is amazing. What is going on here? And then of course I got the official Heathkit manual with all the building instructions and testing and setup stuff. For the next part of the video, I went down to the electronic waste, just picked up a random product I could trash just to show my point. So when I opened this one, I find this little stamp here, ABS, and this is of course for easier recycling, but it also helps me to figure out what kind of material that is. So I believe my Heathkit plastic cover is also made from ABS. So the how to glue, how to repair experiments or demonstrations I want to do, I want to have something else I can break and repair and then compare strength. So let's try and break this and see how that goes, because it is, see, quite flexible, and this is also why it is so difficult to break. But I think I will just use a hammer. So that was real easy. I just gave it a big knock with a hammer and I was able to find all the pieces. And now I can try and glue these and check the strength is good and fine after my repair. And there's also another thing I want to try and demonstrate. The screw posts you always find in all sorts of products, they also crack all the time. And yes, this is also ABS. We can see the marking right there. And let's try and see if I can break two of the mounting posts in one side, and then I will try and repair these, and then I will compare the strength to the two that I don't crack. So they are actually a little bit too easy to crack. What I did is, I mean, this is maybe also unfair. I screwed here, tighten up, and then crack. But anyway, let's go and try and repair this. So here is my repair strategy for this ABS. Here I got some acetone, and my idea is to take some tiny little drops of acetone and put on the surfaces of my fingers. They're in the way. Then dribbity, and tons of acetone here, and dissolves just the first 1/4 of a millimeter of each part. And of course rotate these exactly so the crack matches exactly the broken area. So you have to figure out how to rotate this and put it correctly. Well, that is what I will try and do. You can even drop it a little bit like that. So you want to soak it a little bit, and then it dissolves a tiny little bit of this ABS, and then they will sort of melt together. So after applying acetone to both of the surfaces, you just squeeze them together, and they kind of bind more or less instantly. And of course we need to wait a little bit before we can start working on it. It takes a little bit of time before you gain good strength. Oh, look at that. Oh, that is not super straight. I mean, I should have paid a little bit more attention to detail. Oh, it has something to do with the little rubber feet here. You see, I pushed this all the way down. Oh man, this is a little bit amateur, but I'm sorry. I think you get the point. Let's try and see if I can glue this or melt this part together as well. So here we go. It binded more or less instantly. Just pressed it together and then massaged it a little bit And now let's wait until tomorrow and perform a little strength test. The fun thing when I tried to repair these little thingies here, see? I didn't put one of them completely straight. I was a little bit sloppy. But I think for the, just, you know, to show an example of how you can repair ABS using acetone, I think this is okay for that demonstration. The whole idea about demonstrating these things, that is of course the Heathkit unit. As you saw previously in the video, we had a big nasty hole here, and I was able to find all the parts and melt them in using acetone. And the fun thing is, this little triangle down here that was missing, I restored this as well. And I used tiny little bits of plastic I found in here. Those little standoffs here, I took a little bit of, see here, they aren't really in use for anything. So that is, for me, a little bit of spare ABS material. And then I put it here in a little tin foil container. And I dissolved the little parts of ABS using acetone. And I stirred it and made it into a little goopy goop chewing gum paste. And this paste I put in this little triangle hole, and now it is perfectly fine. I also used some of this goop when it was really, really thin to try and, as you can see here, cover the assembly lines or to fill up the cracks. I didn't do a perfect job on all of the assembly cracks here. This one I should have filled a little bit more, I guess. And then I sanded it a little bit the day after it was nice and dry. So I think this is a lot better compared to how it looked when I got the unit. So now, more than 24 hours later, I was hoping it will be completely dry and fine. So let's just try. Ooh. That is amazing. Oh, let's try and break it. Okay. That was tough. But of course I could break it, and then it did, of course, break exactly the same place. And this is the place of highest momentum, or you know what I mean, the highest force here in the middle, right? When you bend them here, this is of course how it's gonna break. But it really took quite a lot. Yeah, okay. So it is possible to break it. I didn't improve it over the original. I can even see that it didn't melt together right here. What the heck? I only had it perfect here and here. I mean, see? It looks like it didn't really melt perfectly together here. So what I think I did here is I didn't spend enough time adding acetone and massaging the materials so it will dissolve a little bit deeper. But also I wanted to try and do it as little as possible, because I wanted to try and avoid squeezing the measurements and all that kind of stuff. I had the idea I could assemble it again and all that kind of stuff in the beginning. So that was sort of my idea. So I think if you ever want to try and replicate this ABS melting together kind of thing, more acetone, a little bit longer time, and then massage it, together a little bit longer. And then I think, waiting 24 hours before you add super high stress to it is perfectly fine. It really was difficult to break. And so these, they are really, really fragile. So let's try again and try and break the original. I can't even do that with my fingers like that. So let's try and break the one that okay. I didn't get cut. It is possible, and it did feel like I used a little bit less force than the other one. Let's try this one that I glued really, really bad. Okay, let's try first and feel what kind of force. Okay, this is the kind of force I now have a good reference, and then I try and yeah, it's coming. It's coming. It's coming. Oi, oi, oi. Yeah, it is not bad. Not bad at all. Just a few more little minor details I really want to add. I mean, this manual here is just a whole nother level. I found a few pages I wanted to show. Let's see if they are ever going to show up here. Let's see. Earlier, my test programs showed how I could turn different digits in the different segments on and off and all that kind of stuff. And then there is, of course, some routines. And those routines, they are in the ROM, in the EEPROM memory area. So you call those addresses. See, they even say here exactly where they are. They got names, and then you put in input in the A register, and then you do this and you do that, and this solves a lot of practical things for you. And they even have a very nice little flowchart that shows exactly how this is programmed. And I really like this method. So this shows exactly how to use the ROM as a helper for your own programs. And now you know the location for the program. Now you can go, and we can just follow here, but there's also a full listing of the entire ROM. And it is right here. So this is they call this their monitor software. And it is in a 2716 in my unit. That one right there. And here you go. All the different programs with data and the mnemonics, and all that explains exactly what is it doing and why this and why that. Fantastic, isn't it? It's funny to see the printing style here. This clearly comes from a needle printer, and the rest of the text is some other kind of format. Isn't that a little bit funny? And this just goes on and on for a few pages. It is not that many kilobytes of this little program here, but I think that is what I wanted to show. Of course, this hardware is very, very simple. I've already shown there's no other ICs or no other anything inside this. It's all right here. What you see is what you get, except for the power supply, and then the switches for the keypad is down below, so it's nice and flush here. And I should probably show the schematic so we can walk through this real fast. The CPU, we got 16 address pins, we got 8 data pins, and we got the EEPROM with 8 bits, and we got some different chip select signals that's connected to some chip selection ICs. I believe they are located somewhere right here. And we got this, the key buffer. The fun thing about the keyboard, it is connected directly to addresses and datas, and there isn't any read or write signals associated with the keypad. So that means once you go to the right address, you select the right bits, and then you will get whatever you push directly into the data bus. So of course it's not going to work if you write to those addresses, but you of course need to read. And then as long as you're just there at the right address, you are going to get the data. So they really tried to make it as simple as absolutely possible. So here is the schematics. It's just a one pager I found on the internet because I was a little bit too lazy to scan my own schematic. So let's just zoom down here in the CPU area where we see the 8 data bits and the 16 addresses. And then they go to some address decoders, and that will of course enable the different chips depending on where you are in memory. And here to the bottom right we see the RAM, our memory chips, and we got only 2 of them populated. And you can have some optional in a I think it is another version of this. It looks like it because I don't have any additional sockets for this, so I can't really expand the memory in my unit. And we also see that this version of the schematic, we got some decoder driver ICs for the 7 segments. So it is definitely a little bit different. And yeah, I think this is really what there is to it. Yeah, here in the middle, the bottom middle, you see the 3 addresses, 0, 1, and 2. They select the different rows of the keyboard, and then you get in 6 bits of data. How simple is that? It's just amazing, and I really like the way everything is done here. I mean, as simple as absolutely possible, but also it's full of all this software that reads the keyboard and display different values and the addresses and let you modify and read to the entire memory space and all that kind of stuff. It's yet simple, but also very, very powerful. It will let you program your own, your own programs in and run them and debug them and edit. I mean, it's just amazing what they've done. It was done in 1977, and I'm still totally shocked about it. It must have been some sort of a fantastic thing back then. So that is all I wanted to say and show. I have cleaned my unit really, really nice and fine, and I'm super, super happy about the way that everything turned out to be working and to be super easy to clean, and the mechanical parts that was easy to repair. So now I got a really cool demonstrator learning system here. Yeah, I need to find some. The screws there are really annoying on me a little bit, but I will find some for the case. Thank you very much for watching. Bye bye.